Welcome, everybody. Welcome, welcome. Thank you so much for joining us today. My name is Paul. This should be a very different kind of webinar, so I'm excited to get into this with these guys. The guys that are joining me today have been in hundreds, maybe even over 1,000 shops collectively with the four of us. And we've seen a lot of good and a lot of bad practices, a lot of waste, a lot of things that a lot of shops do wrong. So before we dig into that, let's cover some of the housekeeping. There is a Q&A panel on the side of your screen probably. So if you do have questions, please go ahead, put those in the Q&A section, and we will get to those at the end of the webinar. So you are all muted, of course, as is standard practice. So yeah, use that Q&A, and we'll get to those at the end. So Jason, let's start off with you. This was your brainchild. Tell us why we're all here today.
Well, for the few people who don't know who I am, I'm Jason Koger. I'm the local Mastercam guy. I sell and support the software, and my background's a pretty good one. I grew up machining, programming. I swept the floor, worked my way through the ranks, then back to janitor, and now ultimately wound up here. So it's good for you guys because I'm from the trenches, and the things we're going to cover today we've actually implemented in different shops. You know, like Paul said, I've been in hundreds of shops, you know, with the rest of the guys on the panel, and usually it's to go in and solve a problem, you know, make my part run faster. Well, there's almost always a bigger problem in the process. You know, we see a lot of the same waste shop after shop, and, you know, it's not always a cycle time that we can improve that could increase the profitability, but looking at the whole value stream from start to finish. So today's webinar, we're going to cover what kind of waste we see in the different departments of the machine shop. We're going to cover we're going to cover giving you solutions for that, and then we're going to take a look at what the future state could look like. So let's everybody introduce ourselves, and then we'll dive in, right?
All right, sounds good. I'll go first. So I used to also sweep floors in a machine shop, Jason. I actually was a shop owner for about 17 years, started a shop right out of college. I was a machinist and a programmer, an estimator, floor sweeper, of course. And during the time we ran our shop, we actually built some software to help run our company. Grew that shop up to about 75 people, and then eventually sold it and went full-time into the software business. And so now we work with shops all around the world to help make their processes more lean and get more done with less effort. How about you, Brian? Tell us about yourself.
Well, unfortunately, I haven't swept very many shops. I would be willing to, but it's not my background. Yeah, my name is Brian Jacobs. I'm from CG Tech. CG Tech is the developer of Vericut software. Vericut is software to simulate, verify, and optimize NC code. So we're simulating CNC machines. The company has been in business for 32 years. I've been part of the company a little bit more than half of that. In my current role, I cover the Pacific Northwest, and I am also the Boeing Global Account Manager for CG Tech. So that's about it. Brandon?
Yeah, so my name is Brandon. I represent Verisurf Software. So we are different than Vericut, very commonly confused. We got the four first letters, but we're totally two separate companies. But so we're a 3D metrology inspection and reverse engineering software. We work with over 150 devices, anywhere from, say, small scale medical to very large scale aerospace. We cover it all. We interface with a bunch of devices. I've been with Verisurf for about 3 years and about 5 years of metrology experience working with a wide range of different applications. So I'm happy to be here.
Right on. Okay, thanks, guys. So before we really dig into things, let's start by talking about just kind of the main points, what we look for when we walk into a shop, maybe top 3 or 4 things, and then we'll dig into more detail. So when I walk into a shop, the first thing I look for is paper. I look for piles of paper on desks. I look for job travelers. If I see that, I know there's a ton of waste out there. There are people waiting for jobs they don't realize they have to work on. There might be things not getting ordered on time. I go out and I look at the shop floor. I look to see if all their machines are running, or if they're not because they forgot to order a piece of material, or they forgot to get that special ground end mill that someone dropped the ball on. And then I look at their tool crib. If that's crazy disorganized, I know there's a lot of waste there too. How about you, Jason?
Same kind of thing. When I walk in, it's to solve a cycle time issue, but I like taking the shop tour, and the thing that I look for, the thing I hone in on, is big pallets of material next to the machines. I love nothing more than walking into a shop and seeing 300 pieces of material sitting on a pallet in front of multiple machines down a line. I'm also keeping an eye out for what kind of part is running there. Is it, the dash one running on machine one, then machine two, then machine three? Those are the kind of things that stick out to me, and I'm looking for opportunity there.
Yeah, so I'm right there with you, Jason. I think when we go on site, we both kind of look for the same things overall. Oftentimes when I first visit a shop for the first time, they'll try to force me into the conference room, and I always ask for a shop tour up front. First and foremost, it's my favorite part of the job. Getting to see how things are made is just a lot of fun. But really, what I'm looking for is this a well-run shop or is it not? So the first thing that's going to pop out is, are the machines running? Are there a bunch of machines that are sitting idle? What is the complexity of the parts? How long are the run times? Are they using tool presetters? These are all the kind of things that I'm picking up. But first and foremost, I'm looking for scrap. I'm trying to determine, are there scrap parts? Are there a bunch of parts with red tags on them that have been flagged as not being good? And so during this time, it's also a chance to ask a lot of questions that we're going to be able to address at a later time. But I can find out, are you having issues with machine crashes? Are machines going down for any number of reasons? And then part of that shop tour, it's always going to end up at some point in the inspection room. They're going to want to show me their fancy CMM equipment. And, that's a little bit out of my domain, so I guess I'll push it over to you, Brandon. What do you look for when you visit a shop?
Yeah, so I mean, the recurring thing is I like to do a shop tour as well. I look for different parts that you guys do, but when I go in, I mainly look and see where there's a bottleneck with these parts. Most of the time, is it up process or is it at the final end? So I usually look for a stack up of parts, maybe before CMM or after. Why are all these parts failing? I like to see it and look on the machine. If someone's waiting next to a machine, why? Is it quality related? Those are kind of the things that I see a lot of issues with that we can alleviate that process. So I know, Paul, you kind of started off with the issues you see at the beginning and you kind of wrap it up at the end. What do you see?
Yeah, I see people scrambling at final to prepare document packages and get their certs together, get their first article reports in a format that their customer can use. They're often looking at the clock and the UPS drivers coming soon and just trying to get that stuff all prepped and out the door. So that's generally what we see at the end of the process. So that was a good high-level summary. Let's dig into a little bit more detail here. And we're not going to use slides for this next part. We're just going to be talking. So at the beginning, of course, for most shops is the estimating process, right? They get an RFQ from a customer. Oftentimes they are then pulling out a spreadsheet, or maybe, heaven forbid, they're just printing off the drawing and writing on the drawing, an hour of setup time, 20 minutes of run time, $5 a piece of material, $10 a piece in anodize or a lot charge. And those are things that are not going to be easily transferable down the line to the next person that needs to take that information if they're lucky enough to win that order.
So if I could just interrupt for a second, you
Yeah.
mentioned, cycle times, and it's like, how do the estimators actually figure out what those cycle times are going to be? Because, obviously as part of the programming and simulation process, you're going to generate a cycle time that's accurate, but at that point, it's kind of a chicken and egg problem, because you've already now programmed and simulated the entire part that you're just quoting at this stage.
Sure.
And so how do you make sure you get those cycle times right in the quoting stage when you haven't necessarily done the programming yet?
Good question. Yeah, I mean, largely that comes down to, I think, quantity. When I was quoting parts at our shop, if it was, a 10-piece order, the cycle time wasn't that big of a factor. But if it was a 1,000-piece order, you bet we would need to get that down, down to seconds or minutes. So we would sometimes have a programmer put some code to that model if we had it. And if that wasn't available, or if we weren't going to do that, we would often look at the history of similar parts, or maybe that part if we'd run it in the past. But that meant having easy access to those numbers, which a lot of shops don't have, because they have to file through filing cabinets to find, well, what was the runtime on that part. So anyway, so that's hopefully that gives some clarity there. Another thing I look for after that is, and like I said in the intro, I'm looking for piles of work order travelers on people's desks. It's amazing how long it can take to even get material ordered, or for the programmers to even know there's something to work on if they're relying on a piece of paper to go through the order entry, contract review process, over to purchasing, and then finally over to the programming department. And so that's a big opportunity there. But then I know there's lots of wastes that are going to happen in the programming department. So Jason, why don't you tell us about what you see there?
We don't have waste in programming, but but if we did, let's just start. We get a job traveler. Somebody says, Jason, program part 1, 2, 3, 4. Most shops that I go into, and I would say easily 9 out of 10, every programmer is really highly skilled. They have their own idea though of how they want to program a part. And my favorite is right out the gate how we're going to design fixturing and how we're going to select what tooling we use. I mean, if programmer A is in love with the NISCAR tool and programmer B is in love with the Sandvik tool, they run and behave differently. So now we're having two different options to start with before we even lay our first bit of tool path. The other problem that I see, another waste I see in programming is running multiple ops across multiple machines, because we're just already setting up the operators for failure. If we have the ability to run something in a 5-axis and mill complete with tab offs, that's great. But what if we don't have that, right? If we're going to go from op 1 to op 2 and op 3, a lot of the times the programmers already set the guys on the floor up by having 3 different individual fixtures running across 3 different machines, instead of taking advantage of multiple fixtures on one plug and play fixture that goes inside of a machine. From a programming standpoint, it's a little bit more work on our end, but then we're eliminating waste downstream by introducing scrap and error into that. And lastly, when it comes to programming, I noticed that the lot sizes really make a difference. If we're told to program for, like you mentioned, only 10 parts, we would program it with a simple approach, a very quick and dirty get it done. But if we're going to run 1,000, like you're saying, everything has to be dialed into the absolute T. But the real waste is, do we need to run 1,000 at a time? Most of the time, the orders we get are simply to satisfy a batch of 40 per month. Why are we running 300 at a time? And the answer is always, well, it's cheaper to run multiple lots in one batch and do it as one batch. But the waste downstream is really, we're not able to have flexibility. So as programmers, a lot of the waste that's getting introduced downstream, and it's starting with us, is pushing back, reducing lot size, and just getting more efficient with our setups. But so no matter what, you program the job, it's finally done. You may or may not have setup notes we have to create. But as a programmer, I finish my job, it's beautiful, right? And then I throw it over the fence and the guy on the floor gets it. And then I just hope it goes well.
Yep, and then that machinist is going to go root through the tooling drawer, right? Something like this. Have you seen these kind of things in the shop before?
I've worked at that shop. No, that's exactly how. That's exactly how it is.
Me, right? Yeah. Yeah. So anyway, yes, for sure. When setups come out onto the floor, one of the biggest wastes that we see is that there's not enough systems. Like really good description of this exact tool, instead of just like a 1/2-inch end mill with a 1/4 inch round. That would be a ball mill, wouldn't it? But really not having everything prepped for the machine when you go to do that setup. Oftentimes we see someone walk to up a machine with their job traveler, they start looking at the details, and then they leave their machine again to go get something, right? And that's just downtime, spindle's not cutting, you're not making parts. Once they finally do get everything and get their code into the machine, then comes out that prove out time. So Brian, why don't you tell us a little bit about what that process is like?
Yeah, and that's something we hear from managers all the time, especially a manager that hasn't been a machinist or a programmer themselves. They're often asking, why does it take so long? Why can it take a week to prove out a job that's going to actually run for 45 minutes? But regardless of whether or not you're running 1 or 1,000, you still have that unproven NC code the first time that you've got to now figure out, is something bad going to happen on the machine or not? So what happens? The operator gets that NC code, and they're going to single step through each individual line of code, or they're going to turn the feed rates way down, or they're going to do something to make sure that nothing bad is going to happen on this unproven code. If anything doesn't look right, or if something bad does happen, they're going to stop the machine immediately, and they're going to go interrupt the NC programmer, and they're going to try to figure out what the problem was, reprogram that section, repost it, send it back out to the job, and you just have this loop that just goes back and back and forth. And that's what can eat up just so much time. So, you know, obviously the reason I'm here is that there is a virtual environment that you can do that in. You don't have to do it all on the actual physical machine. But once you finally do have, you know, proven code and you're ready to make production parts, you know, that first part, it's going to have to go to inspection. And that's where it's going to go over to Brandon's realm, if you will.
Right, right. And you know, I see a lot of problems in mainly on how, when, and you know, what's the final result of that part. If I, you know, see a whole bunch of red tags on a part, hey, it failed. Okay, why? You know, was there in-process inspection? Were they taking something? Where did they take the part from the machine, take it to the CMM, or you know, what other ways are they doing that in-process inspection? So, you know, a lot of times I see someone at a machine, they're waiting, they take a part to the CMM. It's downtime on the machine. You know, it could take 30 minutes, 2 hours, 3 hours. It just depends on the complexity of the part because they're waiting for a CMM to do that inspection. So I see a lot of shops where they don't incorporate ways to do inspection on the machine. And then there's also ways to automate that. So we look at a lot of CMM rooms. There's, you know, 3, 4, 5 employees. Are they all doing the most efficient job that they possibly can? We see a lot of times where, hey, one person's in the corner, that's their one job, that's the only thing that they are designed to do. Well, what if that person leaves, or what if they call in sick? Is everybody cross-trained? And that's one of the big things that I see, especially not everyone's cross-trained and no one's on the same unified software platform or efficient process. I see 2, 3 CMMs in a room. A lot of times they're running different software. They got them at different times, you know, in the process of that company or the history of that company, and they never took the time to unify something. So let's say a CMM goes down. Okay, how are we going to fix that? Are we going to wait a week or 2 for someone to come on site and fix that? Or is that person, you know, on vacation? We want to basically minimize that process as much as possible. And so ultimately unifying something on all platforms is only the way to go. But I mean, after like a roundabout way of getting to inspection a part, Paul, what do you see?
Yeah, so once you got your part, once you do have it bought off and you finished your job, I mean, at the end of the process, I see a lot of scrambling in getting stuff ready. So like I said earlier, you know, there's often a paper traveler, you know, showing up at the final inspection department or the shipping department. You know, they're needing to pull, you know, some paper forms maybe and enter that into a spreadsheet or some kind of format that they want to send to their customer. If they need to have certs, which is usually the case in aerospace and other industries like that, they're either, you know, again, pulling them out of filing cabinets, going on their network folder, searching for certs, or heaven forbid the cert was with the traveler that might have gotten lost. They might need to call up their vendor again to get more certs so they can prepare that document package. You know, everyone, at least in aerospace that we know and do work with a lot, knows that, you know, you're buying the paperwork just as much as you're buying the parts. So you got to have that really smooth, and very often it just isn't the case. So that was a good summary of some of the waste that we've seen. Let's kind of switch gears here and get into some of the future state, what we have seen shops do well, or ways to eliminate some of those wastes. And I will start first, since I am, we are, you know, really involved in the beginning of that process. And if I was to say that there was a theme that we're probably all going to talk about, it's about standardization, right? Making sure that you have well-defined processes, that people are well trained in, they know exactly what they're supposed to be doing. You're using templates, you're using, you know, pre-configured forms. Those things allow you to be more accurate and a lot more quick. And also to not, and I'm going to pull up a slide here, to not forget things. So one of the things that we highly recommend in shops is to use checklists, right? Some of the most critical things in the world, like surgeons and pilots, use checklists before they do their job. And machining is incredibly complex. I would say just as complex as those things. So having checklists to make sure that you don't forget to do something. You know, even a senior programmer that's been doing his job for 10 years will sometimes forget to do something, right? So standardization is really important. And then I can't stress enough the idea of keeping it paperless. If there is a way to, you know, get your paper travelers, make them digital so that everyone can pull them up on a screen, even if it's spreadsheets that are shared, you know, across an internal network, that's better than a piece of paper that can easily get lost. So, and a lot of also shops, we see a huge advantage to doing more of your planning process up front, right? Just being more proactive, a little bit more planning up front, looking at, you know, as soon as you get a job, you know, we used to have in our shop what we called a war room session that very same day or the next day, looking at how we're going to fixture this part. What custom tools do we need? Is the material a long lead time? And we kick off, you know, activities to get all those things coming right away. And going paperless again will solve the problem of waiting. It'll also solve the problem of motion, of having to walk around looking for stuff. And so once all that's sort of in place, then it's ready to hand it off again to the programming department. You got your material in order, you got your tools in order. What's happening next, Jason, that they can do better?
Well, for my, I know I'd like to agree with you. I think standardization is definitely the key to success. When I'm looking at the shop and how it runs, I look at overproduction. I see that being the most important or the biggest waste from my world. Everything points to being cheaper and how to make parts faster, but I think missing the dollars and the bottom line dollars is probably the biggest thing. Standardization will allow you to do things like building standard tool lists, building templates for your programming. You know, programmers and most people in the shop look at each part and go, that's a unique part, right? My phone is different than my watch. So I'll program it two different ways. But the reality is you can take the same kind of material and apply the same basic principles to it and get through a program much faster, right? Programming is usually not something you get paid for. It's producing the part, right? Adding value into the piece of material. So if you can come up with a standard header for your programs, use standard tool lists, have standardizing for your roughing and finishing so the guy on the floor doesn't have to wonder what's going to be happening. You know, those are huge things from a programming standpoint. Reducing the lot sizes, I think one of the things that people can walk away from is, you know, learning or understanding one-piece flow. You know, most people on the call have already taken some kind of lean class or read a book on lean, right? I mean, we all have. One-piece flow doesn't work in my shop. Okay, it does work in most cases, but it's the principle of reducing lot sizes down to as small as possible will expose waste. From a programming standpoint, learning and programming and implementing standard plug-and-play tooling is going to be critical. Most people like to run big, long batches because it means you don't have to incorporate that setup time. If it takes 4 hours to set up every time you run a job, you'd rather run 6 months worth of parts and only have 1 4-hour block. But if you reduce your setup to only 5 minutes, by doing good tooling in the beginning, then when you get that hot AOG job or somebody comes to you with an opportunity to make really great money, you don't have that machine or that resource tied up for weeks on end running parts. You're able to slip that in, and it's going to cost you a 5 or a 10 or a 15-minute setup. But it really all boils down to standardization. So to finish with what you were saying, you know, Paul, checklists. I'm not a fan of checklists because it means more work on my part, and I am lazy. However, going through, did I use standard tools? Did I use standard plug and play fixturing? Did I use a header? Did I have my tools, my posts, everything dialed in so that you can't distinguish one person from another? That is absolutely huge.
Well, and just to make a couple of comments on a few of the points you're making, I completely agree about the standardization. You know, the more you do up front, you know, even if it's in the programming stage, that's going to help you downstream and all the other processes downstream. So, you know, having a standard tool library that you pull from every time, you know, that's going to benefit you both in programming and simulation. You know, having standard, what we, you know, buzzword these days is digital twin, but, you know, having template files for each of your virtual machines, you know, and having those as just standard things that people don't mess with, that you start from each time, that's gonna help you out. And then with regards to reducing the number of setups, you know, absolutely. And If you have a virtual environment that you can experiment with, you can test out a bunch of different scenarios. So yeah, maybe you want to take this job that's been running in a 3-op, kind of thing, and you want to run it and try to do it in 1-op on a 5-axis machine. You can test all of that in the virtual environment, or maybe the 5-axis machine isn't available and you need to run it on multiple ops. Well, you can test out all those different scenarios, get cycle times, be able to predict, what's going to happen based on whatever it is that you're trying to accomplish. And then once you have a process locked in, you can take it a step further and start looking at other technology like feed rate optimization. And obviously, we're running out of time. I'm trying to be mindful of that. There isn't time to go into how feed rate optimization works, but there is a common misconception that when you start talking about reducing cycle times, it just means I'm going to push the machine harder, which sounds risky, and it would be. And so I just want to emphasize that feed rate optimization is not about just pushing the machine harder. It's not about just speeding it up. It's also very much about slowing it down. It's about maintaining that perfect optimum chip thickness for that given tool at any given point. And then I guess the final point I kind of want to make is, and it falls in line with the standardization, is it's capturing that tribal knowledge that your shop has, before it leaves. Within Boeing, they've been talking about for years, for many, many years, they've been talking about the gray tsunami that's coming. And that's just all the experience that's retiring out. And now with layoffs on top of that, it's getting even worse. So, you got to get away from paper, like Paul's been stressing. You've got to start documenting some of these processes to capture that tribal knowledge. And that includes, feeds and speeds. You shouldn't necessarily have to be relying on a machinist that can just hear the machine and know, yeah, okay, this programmer, it came from this programmer, I need to turn it down to 75% because they're overly aggressive, and this other one is too conservative, I'm going to turn it up to 120%. Capture all of that.
That doesn't happen, Brian.
Oh, I'm sure it doesn't. Yeah. Yeah, I mean, we've had people tell us that, well, we can't optimize our code because the operators mess with the feed rates anyways. And that really shouldn't be happening, because, that knowledge is going to disappear at some point. You need to capture it. So, I guess, Brandon, how do you capture that tribal knowledge on the inspection side?
Oh, sure. I mean, I see that in every shop. And again, it's in every facet of, the process from start to finish. But, in the CMM world, again, I know I mentioned, some companies have 2 to 3 CMMs. Yeah, there's that one CMM that goes down. What happens? Again, the solution is unify that software. I mean, Paul just pulled up this picture. You see a manual CMM. You look at that archaic screen. People are still using that. It's 2020. I mean, it's a great CMM. It's accurate. However, there's nothing we can do to upgrade that. So upgrade to a software, which is totally possible that maybe those 2 other CNC controlled CMMs can also run. But unifying that same software, let's just say that kind of flows into in-process inspection, which kind of steps back a little bit before, it gets to the final inspection. But again, to kind of reduce the amount of waste that you guys scrap, basically, you can have that same file that's on a CNC CMM, manual CMM. You can have that on the same arm. So this is an arm that you can bring to the CNC machine. So instead of wasting the time of, hey, maybe you guys are doing in-process inspection, and that's great. What you could do is you can bring the CMM to the machine, mount it in. So therefore, you don't have any time wasted, moving that part. Or let's say you moved the part to the CMM, came back, you waste maybe a couple hours. What if you realign wrong or incorrectly? You scrap that whole part. So bringing the CMM to the CNC machine is a huge, huge save time bonus. And with that, I mean, there's a bunch of different tools out there that, people are using, and some are using great, but a lot of people are using in the wrong fashion. Maybe they're not accurate enough for that part, So basically what I go in, when I go into machine shop, is make sure, hey, you're using the right thing. Scanners are huge right now. And I would say that some people are using them incorrectly. So if they send a part, hey, it passes on their end, it goes to a customer, they do on-site inspection, it comes back failed. How much does that cost you? One, you have to remake all your parts. You could potentially lose that customer all in the same shot. So basically upgrading everything, unifying, cross-training your whole platform. We see, Jason, I mean, we've had a lot of successes with some of our mutual customers where the CAM programmers are programming the CMM. So if you have that same interface, it just alleviates so much time downstream and saves a lot of money. So with that, I mean, Paul, what's the cherry on top that you see?
Yeah. So yeah, that's great stuff, guys. Again, when it comes down to kind of the end of the process again, having, again, stressing that same theme of having systems, right? Making sure, every customer requires different paperwork, different kind of forms. Some need an AS9102, some don't. Some want a CFC that's special to them, right? Document everything that your customer wants along with those good parts you're making, and make sure it's a system. Everyone knows what they're supposed to be providing. There's not that tribal knowledge that hey, this guy knows what kind of form this customer wants. And then as you ship that job out the door, make sure everything that went into that is well documented and not not that tribal knowledge, right? Make sure it's in your system, all your setup notes, your tools that you used, your feeds and speeds, everything is all kind of packaged up nicely. So the next time you get that job, or if you get a similar part, you can just pull that up in an instant, check it all out, and know exactly what you're doing. So I think that's about up for our time. We're going to open up the floor to Q&A. And there have been some that have been coming in during this time. So if you haven't put any in yet, go ahead and do that. But we're going to start here. Let's see, the first one here, Brandon, what equipment does VeriSurf work with?
We work, I mentioned at the very beginning, I work with over 150 devices, but really we're a third-party metrology software. We do reverse engineering, but for inspection-wise, we work with CMMs that can measure things very, very small. We work with 3D scanners, and then we also work with things that can measure a whole airplane or a SpaceX rocket. We deal with everything across the board. And as far as that goes, what type of equipment, say the CMM, we have a whole bunch of different options. There's Mitutoyo, there's Zeiss, there's Wenzel. So what we can do is we can interface with all those without a retrofit. So it's a great, easy way to save money and get, again, the same unified software platform that I was discussing.
Okay, excellent. Let's see here. This one probably for you, Brian. What does it take to set up a simulator?
Good question.
I guess, yeah.
It's funny that is probably the number one question. Back when we could attend trade shows, that was probably the number one question that people would ask when they would come into the booth is, that all looks great, but how much work is it to set up? And it's an understandable question. Setting up the simulation environment is exactly like setting up a real machine. You need NC code. You need some tools, you need fixtures, you need a stock model, and you need a virtual machine and control configuration. The control is probably the trickiest part because that's what's going to be reading and interpreting the G&M codes, the same exact codes that are going to be processed on the physical machine. But most of those components that I just described, you're also going to be defining in your CAM system. So for example, if you're using Mastercam, you've already got, and we talked about standard tool libraries and stuff, but you've already got your tools, you've defined your stock, all that stuff is already there. And then it's just a matter of using the interface between Mastercam and Vericut to push it over. The only additional work from an end user standpoint is to create a single coordinate system that is just saying, here's where I want you to take all this stuff from Mastercam and dump it on this machine on this spot in the table. And so you just use a coordinate system to do that. But it's really just a couple of mouse clicks and then you're simulating. It's just like if you can play I'm going to date myself here, but if you can play a VCR, you can play a you can play a simulation.
Wow, that dude's old. So, hey, you know what? There's still a question coming, but I had a question, Brian. You had an experience out of a shop where they used the simulation, the verification as a tool to train other people to get better. Wouldn't it make sense to share that?
Sure. That was it's actually a case study that you could go out to our website and go download. And it was there's not enough time to go into all the details about what they did, but long story short, they would pile everybody every Friday. They would pile all the NC programmers into the conference room, and then they would use the simulations to show the machining strategies that they decided to use. And so they would all put the work up, and it was a chance for them to show off their work. And they knew there weren't going to be any errors or mistakes in it because they've already verified it, with our software. But it was a learning tool. Because the more experienced programmers could say, well, why did you do that operation before that operation? Or why did you do the engraving there when you could have saved it for, the other, whatever. But the shop owner, even though, there's obviously a cost associated with that when you're going to, put a bunch of labor in a room at one time, but he just saw it as incredibly invaluable as a way to get the less experienced programmers up to speed quickly, because you had the more experienced ones looking right at what they were doing and saying, hey, I would have done it this way. So, you know,
That's cool.
there's more to that story, but so if you want to hear the whole story and how that went down, because you can certainly just contact me.
Sounds good. Let's see. We have a question here. I guess this is for you, Jason. Maybe we can talk about it together. Is it realistic to do, I mean, or a little skepticism here, is it realistic to do one-piece flow in a job shop? Like, that seems crazy. And let me chime in here for a second.
Sure.
So it is absolutely possible. In our shop, when we first started our shop, we were batch kings. Like, we'd get an order for 1,000 parts that had 4 ops. We would make all 1,000 parts on op 1. Then we'd break the machine down, set it up for all 1,000 parts on op 2, and so on and so forth. And it's, you know, we thought that was the way to go because it minimized your setup time. It was just we thought that was efficient. But we didn't realize until we went through a pretty significant lean transformation that there was huge amounts of wastes. I mean, there would have been times where, you know, partway through that run of 1,000, you know, the tool started going bad. We weren't doing a good enough in-process check, and we scrapped out 500 of those parts, right? And you don't realize that until later. Maybe you're in a second operation or the final operation, and you're finally creating the other surface so you could measure that first one, and then you realize it's bad and there's nothing you can do about it. So we actually went through a pretty significant lean journey, and we developed this process that we called bar to box. And what that actually meant was that we would have a small little right-sized bandsaw, like tiny little bandsaw, right next to the machine. And each machinist, as they're making parts, they would cut that raw material, they'd put it in the machine, or multiple machines sometimes, but they'd, you know, let's say there was 3 work holdings, we'd flip it across 3 different fixtures in the machine. Every cycle, a finished part came out and 1 new piece of material went in. Then we would do our in-process inspection, we would do deburring, we'd wash or clean it, and we'd put it in a bubble bag, ready to go in the box, out to the customer or out to outside processing. So every cycle, from the bar right to the box. And we did almost every job that way, unless it was logistically impossible with size, for example. But it is definitely possible, and there's a huge amount of opportunities to, I mean, for example, you get a customer that has a hot order, they start wanting partials right away. You can start shipping partials, you know, on day 1, rather than waiting for a whole week or more before you have your finally good part out. So what about you, Jason? Any other answers for that one?
Yeah, I mean, from my background, one-piece flow, is it possible? Sometimes yes, sometimes no. Okay, lean isn't just okay, guys, we're going to go ahead and read a book. We're going to, you know, highlight Toyota way until we're, you know, ready to rock and roll. It's the goal in mind. You know, sometimes it doesn't make sense to run one piece all the way through a process, but the idea of you're running a little bit, you're checking, you're running a little bit, you're checking, it gives you flexibility. So even if you're just a job shop and you're getting a PO for 200 parts, you know, there's always that conversation back with the customer. Do you really need 200 parts, or do you really just need 40 a month? So I think there's a little bit of a trust, you know, if you're tier 2 and the tier 1's giving you the job and they're saying, give me 6 months worth of parts at one shot, there might be a negotiation back. Let me go ahead and do 1 month's worth of parts. So there's a little bit of a communication there. But even if they say, no, we want all 6 months, the idea of one-piece flow allows you that flexibility, like we're talking about with getting a hot job. I mean, Paul, you were at your shop, and if somebody came in, as it's fantasy, right? But it happens often enough. I'll give you $1 million if you can crank out this hot job and you got a week to do it. What a bummer it would be if you're 400 parts into a 1,000 part order, and then you're paying guys through the nights and through the weekend to hurry up and get it done so you can get to the next job. So the theory of one-piece flow, where everything is fluid and everything can be adjusted, I think is critical. It's not just is it possible, it's a necessity. You have to get your shop to the point where one-piece flow is as close to possible, so that you have the maneuverability to take more money when it's available to you.
That's great. And this kind of feeds us into the next question. This is from Chad. He says, many shops are aware of the need to reduce waste, but are disconnected from the pursuit due to lack of manpower. What would we suggest to build better standardization in programming, tooling, simulations, and inspection planning? It's a good question.
That's a
Yeah.
good question.
So Paul, if you don't mind, I'd like to take just the very first part of that.
Sure,
Many
of
shops
course.
are aware of the need to remove reduced waste, but are disconnected from the pursuit due to lack of manpower. I've worked at a shop that only had 15 guys in the whole entire company, and all 15 guys were versed and trained with basic lean implementation tools. So even if you were just a 3 or a 5-man shop, you know, getting by, there's no reason not to expose everybody to a lean thinking and a lean process, and then making your employees responsible for coming up with the ideas to implement them. It doesn't have to be a I'm the manager, I'm the king, I'm the boss, and you all do what I say. A lot of that principle of lean is it should be given the tools to the group, and then they should be the ones moving it upstream. So if you have a lack of manpower, well, that's great. Getting everybody cross-trained and getting everybody, you know, learned up, if you will, on lean thinking is step one. So go buy Lean Thinking by James Womack, make everybody read it 4 times, and let's have a conversation about what are some of the basics we see right now that we could do to improve in our shop.
Well, and yeah, and I think you're making some really good points. But when it comes to reducing waste, you have to be able to recognize it to begin with. And, you know, we see a lot of shops out there that have this mentality of, well, we've always done it this way, and they don't even recognize the waste to begin with. You know, I used the example earlier of the managers that complain about prove-out time. So my next question is naturally, okay, well, what percentage of your machining time is spent on new part prove-outs? A lot. You know, it's not even tracked. It's just, you know, it's just a cost of doing business. We just have to go through that process, and they can't even tell me how much time is spent. So until you start tracking that stuff and recognizing it, you can't really start chipping away at it. So I think that's a really good, you know, multi-part question there that we could probably spend 2 hours diving into.
Yeah.
Yeah, I mean, from the inspection side for Chad's question, I mean, there's a few different ways that you could do it. So, I mean, let's just say you have one person in quality or 2 people in quality. There's ways to automate that process. So, I mean, yeah, depending on what tool you're using to inspect that part, usually inspecting it's the quick part. The reporting side is what takes a long time, where you have to input the tolerances, you have to create a plan. What if that's all automated? So maybe if you run this part maybe 10, 20 times, you can follow a sequential plan. Or let's just say one person's a little bit more advanced than the other. You could basically say, have that advanced person write out this plan. They don't need to understand GD&T. They don't need to understand the tolerances. All they have to do is just follow these simple guidelines on where to touch off on the part, and then it will create a nice, clean report that can be sent to the customer in an automated fashion. And that's what we see a lot.
I'll add something hopefully is a little bit practical. Not that those weren't, but in our shop, talking about sort of lean education. So we put up posters all over the place of the various, you know, like 7 wastes of the Toyota production system, and we had training sessions during some of our, you know, company meetings about what those wastes were. And we sort of drilled it into our employees' heads enough that they started to recognize when they were doing something wasteful, right? Before you understand those, it's hard to kind of put it together, but once you really have it drilled in, and then what they would do is we would have these little Kaizen newspapers, basically just a sheet of paper or a pad mounted into each area, and people would just go right over to that and say, I'm doing overproduction right now, right? Write down what they were doing. Only took a minute or 2, and then once a week, a team in that department, whether it was, you know, the programming department or the mill department or the prototype department, or even up in the office, we would have these Kaizen meetings for like 30 minutes once a week, and we would we'd look at everything that was written over that week, and we just start coming up with solutions. Well, how are we going to solve this overproduction or this waiting time? And a lot of times the solutions are pretty simple. You just got to put your collective brain power to it, and you can come up with some pretty good stuff. So that's something that worked well for us. Hopefully that's useful. Thanks for your question, Chad.
Oh,
yeah.
Go ahead. Sorry, go ahead, Brian.
Well, I was just going to say there's a lot of technologies that have been coming online too. You know, I don't even think that are offered by us, but you know, these machine monitoring, you know, capabilities, and even the machine tool builders have been building this capability into the controls, even though there aren't that many shops that are utilizing it yet, but knowing that it's coming. You know, and once you start monitoring all these processes and can document it, again, you can start chipping away at the inefficient processes. And so, I encourage everybody to be constantly going out and looking at the technology that's available out there, because if you don't do it, your competitors are. And if you want to be in business in the long term, you're going to have to stay ahead of the game, which means investigating the latest technologies that are available. Another trend that we're seeing, and I think this applies to all four of us here, is software being available on a subscription. And there's pros and cons to that, obviously, and it's a different ROI for any given shop. But it is a lower cost point to get into a technology. So if you really just want to test it, that's a good kind of non-committal way to do it. So again, I just want to stress that, stay out there, keep looking, keep looking at what's coming.
Yep.
So, hey, Paul.
Yes.
So, do you mind if I jump in? I had a question. I want to put everybody on the spot,
Absolutely.
man. I really want to.
Go for it, man.
We got so many questions, but I was noticing that some of them are the same one, just worded differently. What if I don't think I could afford to be lean? I mean, I guess that's one of the ways that those worded. Another way is a small shop. I can't afford to stop everybody to do Kaizens. I don't have enough guys. We're supposed to stop every Friday for an hour to cover lean practices. I mean, does anybody have something they could say to somebody who's afraid of the cost of going lean, or to maybe change the status quo and switch over to something new? I mean, I've thought of it. I can answer it first if you guys want me to be the guinea pig.
Yeah, go for it. Go for it.
Well, for me, as tough as it sounds, I don't think everything revolves around having to spend money outright. I mean, there are solutions out there that have a cost to it, and then a cost to implement it, and then a cost to train somebody. But really, I think it starts with a desire to improve. If you think you're doing good right now, maybe you are, but I picture our industry and I picture machining as kind of like walking up the sandy slope. If you're standing in place, you inevitably are sliding backwards. Everybody else is making the next step forward. They are progressing. They are using new technology. And just because you think you're in a good spot now, if you are not taking steps forward, ultimately you're going to be sitting there at the end going, man, I remember the good old times, and now they're not good, right? So don't have the cost, or I don't have millions of dollars to go out and buy brand new equipment or millions of dollars to revamp everything. I think that it starts with invite one of us in. I mean, I don't know. Up and down Washington, I go into people's shops and we have 4-hour conversations about, let's take a look at what's not working. I mean, I think everybody else in this panel does the same thing to some degree, right? So yeah. I think step one is, before you go out and spend millions of dollars trying to build some space age new revolution machine shop, get us in for a conversation. Let's take a look at what you got going, and let's just do a deep dive and see if you even need to spend any money at all.
When I recently saw your old shop, Paul, one of the things that stood out to me was the fact that almost everything aside from the machines had wheels on it, and that you guys had the ability to push the equipment around for whatever made sense for whatever given job. I mean, that really stood out to me.
Yeah, and and Ryan here is putting in a comment. Lean doesn't mean spending a ton of money. It's true. I mean, yeah, we bought some casters, put them on our granite tables, put them on our bandsaws, put them on our vacuum pumps, put them on our hot saws. We'd reconfigure a workstation depending on what job we were running. And yeah, it was just, benches made out of 2x4s with casters on the bottom, right? A lot of times we would prototype out someone's, Kaizen idea with duct tape and cardboard, right? See how it's going to work. Try it out. Don't do something super fancy right off the bat. Don't go buy a bunch of steel, weld up a really custom table, and then realize when you start trying to use it, oh, we forgot about this other thing, right? So start cheap, start easy, and then evolve it over time. Let's see here.
That fits in perfectly with what some of the questions coming in. A lot of comments along those veins for sure.
Yeah. From John, yeah, start small, even if it's just moving a garbage can or a light, you'll feel better along the journey. Yep, that's absolutely true. So there is a question that's been on here. Jonas, want to get to it? It's for me, obviously. How can ProShop help companies keep track of their cutting tools?
I'll take that one. No, I'm just kidding.
So we have a cutting tool module and what we call an RTA module, which is rotating tool assemblies. And essentially, it allows you to first identify your entire tool library, right? And we can import that even from like a Mastercam file as CSV data. But it allows the programmers to then uniquely specify, right? This A37 mill, which we buy from GAR, and has these specs, is the tool that we use for this job, right? And it has its vendor associated with it and its price. So the way that helps is that when the programmer says this is the set of tools I need, right, that feeds into purchasing, so they can make sure every one of those tools are going to be there. And they'll even say, this is a steel job or a titanium job, so I'm going to go through a bunch of these. I think I'm going to need 10 of these end mills, right? So everything can be here when the job is to set up. And then out on the shop floor, you can organize your tools by those tool ID numbers, actually. It's actually better than organizing them by style. And then the machinist will know exactly what tool to set up in those holders, with what extension length, what kind of collets. So they're not rooting around that drawer of half-inch end mills, and you have 16 different kinds of half-inch end mill, and they're trying to guess which one the programmer meant. Anyway, so that's just a little bit about how we do that.
Paul, I just want to correct you too. The problem was you're using GAR instead of Sandvik.
That's probably a good point. Yeah. And you can have multiple approved vendors for, maybe it's a style of tool, right? This kind of coating, this kind of corner radius. Thanks, Jonas. Let's see here. Yeah, lots of just positive comments about starting lean. Ryan, two-man shop, we just start organizing. Let's see here. Well, we still have a little bit of time.
Hey, get those questions in before we're done, huh?
That's right. That's right. So
we can keep. I'm sorry. We can keep answering questions, but do you want to put the slide up with our contact information in case anybody just wants to have additional questions offline? People are probably sick of staring at our faces anyway. So.
Yeah.
I don't know. I mean, I shaved everything right here for people. So, I mean, I don't know. I feel pretty today. But no, I know most of the people on this call too, and if you forget who's who, don't be shy to reach out. I'll direct you to the right guy. That's totally fine with me. So yeah, that's some good looking dudes right there.
I need a new picture. That's like 10 years old. I definitely am older than that now. All right. Let's see here. Let's see. There's a lot of comments that are just comments. That's nice, you guys. Thank you. So here's one. Is it realistic to go paperless? It is realistic, and it's totally possible. Yeah, a lot of machinists especially are fearful of doing that. They like to hold on to that print, that big B-size print that they can just look at up close and sketch things on and write their little notes. And I guess I'll say that that's even having that is not necessarily a problem. But we need to provide mechanisms for people to share what needs to be shared down the line with others, right? So programmers, rather than printing off their setup sheets and the paper, put them to PDF file and make them available out on the shop floor. We have a page on our website where we talk about shop floor computers, right? They don't have to be super expensive. You can, for $300, you can be all in on a 24-inch monitor, a computer, keyboard and mouse, and a stand for it. And you could pull up PDF files from there. You could pull up spreadsheets from there, or images. Taking screen captures of your Mastercam file, even those simulation videos. Those, I think, right, Brian? You can have those as an executable, so you can just run it and watch those, right?
We did that at my last shop, doing nothing but surfaces. Everybody was able to carry surfaces around from computer to computer.
Right.
So you're saying it's spot on. It should be paperless.
Yeah, yeah. And then, of course, you're going to have to put stuff back in. So having your inspection forms, not be paper-based. So spreadsheets are a great solution for that. Of course, some ERP systems have built-in inspection, many don't. But that's, that's got to be part of the equation too. But it's definitely possible. and the improvements that you can see on that, the return on investment of getting rid of paper is enormous. You know, not just the cost of the paper and the cost of those expensive printers, but all the waste that's associated with that. All right. Let's see here. Can we get a temp license to test out your software? Anyone want to take that one first?
I mean, I'll do it, but I mean, I'll start there if you want. The answer is absolutely not. No, yeah, you can get licenses, but it's only as good as the driver was familiar with the machine. I've had the pleasure to try driving a Lamborghini before and stall it out about 30 times before I even got out of first gear. And that's where, that's really, from my standpoint, that's where who you choose to partner with makes all the difference. I know for our company, sure, I can get you a license, but I insist on hand holding and making sure you know what you're doing, getting you up and going. And then if you want to take off and see what, you know, see what it can do, be my guest. But we absolutely insist on working with you step by step to make sure that it's successful. I mean, same with you, Brian.
Yeah, that's always our concern as well, is the, you know, the training factor. You know, the simulation does not, like I described earlier, it does not have to be complicated at all. It can be a matter of a couple mouse clicks and hitting go. And then there's a bunch of analysis tools available to you. But, you know, this is also a product that's been around for 32 years. And, you know, we have to support the most complex CNC machinery in the world, and people do some crazy stuff out there. So if you start just poking around different menus and windows and opening things up, very quickly, it can just look overly complicated. And then people are like, this is too much complication. So that's always the concern about just saying, here, try it out, without providing some kind of training along with it to say, here's how you're going to step it through it with your process. So that's just something we would want to address for sure.
Right. Yeah, likewise, same thing. It's just a recipe for disaster if we just give you a license and don't hold your hand, but we will. I'll come on site, you know, depending where you're at with code restrictions, I understand, or, you know, we can do a go-to meeting or a web demo like this. Yeah, we'll be here to assist you anyway. So.
Yeah, and same exact for us. We have demo systems that we give credentials into to play around with it, but we always do training sessions up front, and typically have the first couple of times where we're just there kind of watching over your shoulder and showing you what to do. Because, you know, all of these products are super involved, super complex, you know, powerful, of course, but that means you gotta learn it, so you're not stalling out your Lamborghini 30 times.
That there is very few things that's humiliating as thinking you're super cool, and then you're going to show everybody how cool you are, and then I'm not qualified to drive this car. I guess I should have paid better attention to the instructions. It's pretty humbling.
Yeah. We probably have time for one more. Here's one here, I guess for you, Jason. How do we? What are some things we can do with our programming software to make it more lean, or to make our process more lean?
Oh boy, you'd make me the last question and tell me I've got 60 seconds to do it, huh? Okay. What can you do to be more lean? Well, I'll say this: checklists. They're a real bummer to have to follow a checklist, but there are. If you developed a checklist for programming, did I use a standard tool list, or am I reinventing my own every single time? If you have your half-inch MLs tool 1 in this machine, 3 there, 5 there, 7 there, there's a lot of setup involved going from program to program. So build a standard checklist of use standard tools, use standard fixturing, make the header of my program look the same. If you have a post that doesn't behave the way you want, let's get it fixed. So I think there's a lot of standardization and a lot of focus on plug and play. And then really, even with programming, I mean, the toolpaths are one thing. You know, you can learn whatever software you're using, you can learn how to drive that software. Somebody out there will help you. And if you're in, you know, Northwest, I'm the guy. But I think that a lot of it has to do with building standard practices, and then, you know, being religious about making sure you follow them. I think that's a big key. And then feel free to reach out to the Mastercam guy, the MLC CAD Systems, Jason Cover, the one with the goofy smile. Go ahead and you know, make sure you take that email address down and say, I've got a question. Of course, we'll work with you on that.
Yeah, and so Justin has a similar question here. He says, we have 4 programmers and lots of legacy programs and standard tooling. The problem is trying to get standard programming methodologies and feeds and speeds and depths of cut. Is there a decent way to gather all of that legacy information into a standard database?
That sounds like a programming question.
Yep.
You want it, Paul, or do you want me to do it?
No, you go for it. That's you.
Oh, man. Okay. So this is my opinion. Now that I've said that, I think going back to legacy programs, I just archive them and deal with them as they come up. But let's say job 1, 2, 3, 4, we've run 100 times, and now we're implementing these new standards. I would say there's nothing that I've seen that'll just go through a code and say, oh, you've used a half-inch ML, 100th out depth of cuts, 75% step over. I don't see a lot of that. I've never seen software that'll do that. What I encourage people to do is you're going to have a programmer you trust, right? There's a guy that you go, that's the one, you're going to develop my systems. If you're cutting 718 Inconel and you know that a 5% step over with this ISCAR tool at this depth of cut works, build that as a template in your software. So that anytime, doesn't matter if you're the superstar programmer or the junior programmer, he's able to bring that toolpath in. It's going to have his depth of cut, his step over. It'll even remember speed and feeds, at least in some of the software. I know ours does. So build a template for that specific application for that one toolpath. Then when John Doe takes program 1, 2, 3, 4 from the dark ages to today, and you're going to reprogram it or rerun it, when you see a roughing routine you know has just been a problem, bring in your template for roughing Inconel, oh, excuse me, roughing 718 Inconel, and then pick that geometry and drag and drop it into the new toolpath, and then you'll have applied the new standards to an old way of doing things. I don't think it's necessarily valuable to go through old legacy program, reprogram from scratch, but if you always have that one roughing routine that's been crap, no problem. Bring a new process in, reassociate geometry, and then copy and paste it into that section of program.
Now you can drop it into a simulation program, and then you would be able to gather some of that information. But again, you need the same stuff that the machine tool would need. So you would still need some tools to find. You'd still need to know what machine it was going to be run on. You'd have to have a virtual equivalent of that same machine. But then it would. So if you just wanted to take the jobs that you know run really well and you wanted to gather information out of those jobs, you could set up a simulator for just that, and you would be able to pull all that feed and speed information, step over, depth of cut, volume of material being removed, all of that stuff would be analyzed. So, but it would be, I mean, if you had a whole bunch of legacy programs, that'd be a big undertaking. So not an automated way.
There's no doubt.
No automated way.
Yeah, it's a big undertaking no matter what, but those are great points, you guys. So we do need to wrap up. There's one last question I just wanted to get to. This company says they have more than 30 machines, 60,000 square feet. It's a big outlay to go digital everywhere. So what I would say about that is, I mean, first of all, look at how little you can actually spend on a device. You know, there are ways using like a little Linux box, a Raspberry Pi, you know, where you can probably be up and running for $200, you know, monitor, keyboard, mouse, computer. And then starting with a lower density, right? If you have a cell of machines where there's 3 machines all close to each other, or a couple of lathes facing each other on a bench, right? Just start with one and share that. And then kind of over time, kind of increase your density of devices. Or if you have fewer people than machines, then just give people, you know, a Chromebook or something like that is pretty inexpensive, and they can just kind of carry it around going to the machines they're working on, or some combination of both. So anyway, just a couple of tips on that. I do think we need to wrap it up. I know I'm late to another meeting already, but thank you everyone for all your time. Hopefully this has been useful for you. Thanks for all your great questions. And we will send out the recording for this and follow-up email if you guys have any questions. Please don't hesitate to reach out to us.
Yeah, thanks everybody.
All right, well, good job you guys.
Thank you.
Yeah, thanks.
Thank you.
All right.